Hey calculus people, I wanted to make a video of the answer key for 3.3a because it is so important for your ability to do harder derivatives that you get this easy power rule derivative down perfectly. Like, this is a step that's in like every derivative you will ever take, so it's super important you do these well. So if you go through yours and you don't know how to do something, make sure you check this out and correct it. All right, so we're going to start off easy, and compared to our old version, this stuff's really easy. It shouldn't take me long to go through. Remember when we did limit definition derivative, how long this would have taken? She would have gotten like the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. And then you have to plug all that in, factor, distribute, cancel, and do the limit. Well, now we got the shortcut. And remember, the power rule is the easiest one. And you bring the old exponent in front, you knock it down one, and we do that on the other one. And remember, like if it starts off as a 1, you take the old exponent in front, multiply it, you get 2, and now it's x to the 0 power, which makes it disappear. Or a good way to remember it is basically the x goes down a power every time. So the 2 goes to a 1, the 1 goes to a 0, meaning it's not even there. The derivative of a constant is 0. And one thing I want you to notice, it was f of x, so this one is f prime of x. Make sure you have proper notation. Okay, don't get lazy on that. So if this one's y, then its derivative is y prime. This is going to be 3x squared. The derivative of 9 to 0, so I don't even have to write plus 0. Alright, so we're cruising, man. G prime of x, because I follow their notation. This means the slope of that line at any time. Should not be a shock. Remember slope-intercept form? Y equals mx plus b? Well, guess what m is? Your slope. Does that confirm your thoughts? Heck yeah, it's a constant slope. That's a line. This is going to come into play later when we do projectiles. So it's good to get a look at it ahead of time. S prime of t. It's a distance kind of thing. So I multiply 2 times what was in front. Remember, we didn't have to do that on these, but if there's already a number there, you multiply it. So that's negative 32t plus, and this is 4, then plus 0. Eventually, you kind of like stop even seeing constants. All right, and then you get to here, don't be a rookie. Remember, the derivative of 0 of any constant. And the reason for that, like if I graph that, what would that line look like? It'd be a horizontal line down here. I always like you to think about it. If that's my x-axis, that's my y-axis. This is the line y equals negative 2. Guess what the slope of a horizontal line is? 0 everywhere. That's why the slope formula, which is f prime of x, the slope at any point is 0. Just like up here, the slope at any point on this line is 3. Then we get to this. So we got, multiply those 6x squared minus 2x. I bring the 2 in front, knock it down 1, and plus 3. Okay, and bring it down, knock it down 1, you get 0. So this is the equation of the slope of that at any point. So we're just cruising and doing good notation. 20x to the third minus 21x squared plus 13 plus 0. Boom. Right? Now be careful on this one. This is a sneaky snake. Okay? Don't do the derivative like you see it. You don't get to do the derivative of the top and the derivative of the bottom. That would be terrible. What you should do is rewrite the problem before you take the derivative. And that would be any x value, or any power on bottom when you bring it up has a negative exponent. It's kind of like the price you pay. So now that I rewrote it, I can use my rule. F prime of x is negative 4x to the, remember you got to make it go down one more. Like a 3, you subtract 1, you get a 2. A 2, you subtract 1, you get a first power, right? If I subtract 1 from an already negative number, it gets more negative. So don't be a rookie. Okay? If I rewrote that in a nice version, it would look like this. okay, because the 5, if I drop it back down, don't take the 4 with it. The 4 is not being raised to a negative power. Okay. Now we take it up a notch, and we're going to find the slope of a tangent line. That's what we did when we learned the long way in limit definition of derivative. It's kind of one of the purposes of a derivative is to be able to find the slope and equation of a tangent line. We'll talk about applications of that later. But right now, I just want to find the slope of a tangent line that's on this graph that goes through the point 3,7. Okay, so if I graphed it, it would look like this. Here's your, what's that? Parabola looks like this. Okay, 1, 2, 3. Oops, 3's out here. And up at 3,7, you want to know the equation of this tangent line. It's a pretty steep line, right? So how do I find it? Well, it's pretty easy. Just take the derivative. I don't have to do that long limit definition of derivative. And I can find the slope at any point with this equation. So I want to find the slope at this point. So f prime of 3 will tell me the slope when x is 3, which is 6. That's a pretty steep line. Well, now you need to remember this equation. Y minus y1 equals m times x minus x1. And you just plug in your points. Y minus 7 equals my new slope I just found out, times x minus 3. And maybe I like to be fancy and change it into slope-intercept form. Right? Awesome. Same deal here, but be careful because make sure you do negative 2x to the negative third. Make it go down a notch. Or if I were to rewrite that, I might want to rewrite that as negative 2 over x to the regular third. The reason I want to do that is because if I'm going to find the slope, I'd rather have a slope written as a fraction than with a negative exponent. That just gets confusing. So my slope at the point 2, 1/4, I don't have anywhere to plug the y in. I just have somewhere to plug this x in. It's right there. It's negative 2 over 2 cubed. So the slope at that point is negative 1/4. So it's a not very steep negative slope. Then if I want the equation, y minus the y part equals m times x minus the x part. And then you distribute that out. That'll be plus 2 over 4, or plus 1/2. And then you add a fourth to both sides, and you get negative 1/4 x plus 3/4. Okay? And then, now we're to the back. So that's like, here you're taking a derivative, you're taking a derivative, derivative. What the heck is a derivative? That's why I like putting these problems in here. Derivatives find slope at any point. So if you're asked something like find a tangent line, you're using the derivative to find its slope. And then once I find the slope, I can write the equation of the line. So, all right, now these are just sneakier because we have not yet learned the rules for these. We'll learn the rules probably tomorrow on how to deal with situations like this. Tomorrow and the next day and the next day. Basically ugly ones. But right now, the only rule you know is power rule. So if you see a problem that is way more complicated than these on the other side, these are just basic. There's nothing to simplify these. Maybe that last one was a fraction, but so what you have to do is you have to simplify it first. See, it's not y prime. I am just distributing. I'm not taking the derivative yet. So what do you get when you get 3x times x squared? You get 3x to the third. What do you get when you get 3x times 2 over x? I don't know if you remember this, but you can write that as a fraction if you want. And you're doing top times top, which is 6x, and bottom times bottom, which is x. I'm doing it off to the side because I want to write just a minus 6. Okay, so basically the x on bottom cancels with that x up top, and the 3 times 2 is 6. Now that's not the derivative, so be careful. That's why I said make sure you're doing your notation, because now that I'm writing y prime, I know I'm going to do my rule. I didn't do that trick that we did on the other page yet. 9x squared is the equation for the derivative. Okay, same deal here. Don't take the derivative yet. I want to rewrite this as 5 minus x times 5 minus x, right? Or I just do the rule. And notice I'm not taking the derivative yet, so I'm just foiling this. You can go through and FOIL, but I know a trick for that. You do the first term squared, you do this times 2, which would be negative 10x, and then you do the last term squared. Okay, and then I take a 3 to each piece. So still, did I take the derivative yet? Nope, I haven't used my new rule. 75 minus 30x plus 3x squared. I like to write it in the correct order before I take the derivatives. I could have done that earlier, but I don't know why I didn't. Okay, and then we do this. Now you use your rule. You take the old power in front, and you knock it down 1. You take the old power in front, and you knock it down 1. That's the slope of the original line. Okay, now here's a fraction problem, but if there's a single term on bottom, you get to do this trick. I can split it into this over that, and this over that, and this over that, and this over that. If it had a plus down here, you couldn't do this, so be careful. You don't get to do this trick very often, only when there is a monomial or a single term on bottom. So what do you get when you have 4x to the third over x squared? Maybe I'll just write them out this time. Now, this one simplifies. Notice I'm not taking the derivative yet. I'm just simplifying. So if I have 2x's on bottom and 3x's on top, they'll cancel over and you'll be left with 4x. Here, I have x squared on top and bottom, so it just comes out to be minus 3. Here I have more left over on bottom, so it becomes 7 over x. Now, instead of writing 7 over x, I would rather write it as 7x to the negative 1, because I know I have to do that to take its derivative anyway. Here, nothing cancels, but I'd rather write it as negative 8x to the negative 2. So I'm basically making life as easy as possible for myself for when I do my trick. So remember, here's just power rule. That becomes a 4. This becomes a 0, right? This becomes a negative 1 times 7. And don't get rid of the x. It's actually x to the negative 2. And then this one becomes plus, because a negative times a negative is positive, x to the negative 3. Now, it would be truly professional if you took the time to rewrite these by dropping the x squared and x cubed back to the bottom, but I ain't got time for that. Okay, so next one. If you ever have a one of these, basically, you can rewrite it as x to a single power. And just remember, anything x is raised to goes on the top of the fraction. Any root goes to the bottom. So this x squared in a cube root becomes x to the 2/3. Now that is really easy to do your trick on. You bring the old power out in front. See, I'm writing f prime. You bring the old power out front, and you subtract 1. Now be careful, because when you take 2/3 minus 1, you end up with negative 1/3. Now I'm going to make this one look pretty because I didn't do it here and I feel bad. So I'm going to rewrite this as cube root of x. Oh, that's crazy looking. You could rationalize this, but I don't want you to. The 1/3 power means a cube root, and why did I put it in the bottom? There's already a negative sign on it. A negative exponent means this guy needs to drop down. And if there already is a fraction line in your problem, there's already a top and a bottom. You don't need to put it down below anything else. All right, that's it. Check the last one later.